Good day, viewers. Excuse me. I'm here, Mr. Nyati, your presenter. This time around with a video to do with organic chemistry. So I thought I should go through a past paper in 2019 GCE, Science Paper 2, and pick a question which would have a wider view of organic chemistry. And this is section C. In section C, C3, question C3, this is the question which basically looks at organic chemistry. I thought I should come up with this question. So pardon the noise that is in the background. These are basically learners making some noise. Nevertheless, let me proceed. But before I get into the gist of the matter, may I say that subscribe to my YouTube channel, hit the like button, the bell button, and also leave a comment in the comment section so that I hear your feedback about this. So we get started. The question says, the series of processes below show the link to the formation of an ester known as ethyl ethanoate. Okay, so this whole process here, it all goes and leads to the formation of an ester. But look at what it starts with. It starts with ethene. Then there's a process, we have ethanol. Process, M is produced. Then a process, then you have ethyl ethanoate. So now, there is a question from the reaction scheme above named processes KLM. Okay, so now we get started. First of all, what you need to understand is the fact that ethene belongs to alkenes, okay? Ethene belongs to alkenes. Now, alkenes have a general formula of CnH2n, okay? Where N starts from basically 1. So, alkenes, I must mention that alkenes are basically unsaturated hydrocarbons. Unsaturated hydrocarbons. What does it mean? It means that a molecule of alkene has a double bond, okay? Has a double covalent bond between the carbon atoms. And because of that double bond, it has not acquired the maximum number of hydrogen atoms that are supposed to be bonded with it. So because of that, it is referred to as unsaturated. For example, the first element in alkenes starts, because there is a double bond, carbon to carbon double bond, it should just start with 2 carbon atoms. So here we are, we have this as the first element, not the first element, but the first molecule, pardon me, the first molecule, okay, has this, okay, is this because of the double bond. And how do we find that? We normally say that where there is N, we put a 2, then H2, and then we put a 2 where there is N. So we have 2 times 2, that gives us 4. So we have CH, C2H4. So this, because of these 2 carbon atoms in organic chemistry, the number of carbon atoms are always represented by a prefix. So you have some of the prefixes that you need to know. For example, you have meth for 1 carbon atom, eth for 2 carbon atoms, prop for 3 carbon atoms, but for 4 carbon atoms, and pent, let me end at 5 because that's what your syllabus prescribes, for 5 carbon atoms. This is a prefix, okay? And then this is number of carbon atoms. So this is what you should know in organic chemistry. This is one of the things, okay, that one needs to understand when you go into organic chemistry. So this is the prefix. So naming of organic compounds in organic chemistry is referred to as nomenclature. and it takes into account of two things. Number one, the prefix. The other one is the suffix. Now, a prefix is basically the beginning of the word, okay? So the suffix is the ending. I'll give an example of prefix. The word mother, for example, you have mother. Mother can be motherboard, motherhood, mother is, and all those things. So the word mother is a prefix. And then you have suffix is the ending of the word. So you have, for example, meant. Okay? That meant, you can put it on entertain, entertainment. Okay? Moment. Okay? And so on and so forth. So now the suffix basically looks at the family to which an organic compound belongs. Okay? For example, you have the one which ends with ane. This one belongs to the family of alkenes. ene belongs to alkenes. Okay? You have anol, alcohols or alkanos. You have anoic, which is basically organic acids or carboxylic acids. So these are some of the things that you need to basically know in organic chemistry. Okay? So having said that, we are saying that for the alkenes, okay, for the alkenes, the first molecule or compound starts with 2. Why? Because these are unsaturated. No matter what, there should be a double bond between the two carbon atoms. So because of the double bond which should exist, you cannot have a one carbon atom with a double bond bonded to hydrogen. No. Okay? So it demands therefore that two carbon atoms must exist for the first one for you to have the double bond. Okay? So this is the first one, and it is called ethene. Okay? This is ethene, and we've just discovered from this formula, from this general formula, that the ethene has 4 hydrogen atoms, and we derived at this using this formula. So now, this ethene, okay, this ethene is an alkene. Now, what should we know about alkenes? Alkenes are basically, maybe we also put the third one. The third one would be like this, okay? So one thing that you need to be careful with is the number of bonds that should exist. Remember, carbon has a valence of 4. So there should be 1, 2, 3, 4. This one also must have 4, but remember it already has 3. 1, 2, 3. So add only 1. Okay? Then this one has 2, so you add 1, 2 to make it 4 bonds. Okay? So because of this, it is unsaturated. You break this, then it has the maximum number of hydrogen atoms that are supposed to be bonded to it. Okay, so this is called propene. This is called propene because you have 1, 2, 3. Remember, 3 is 3 carbon atoms, and that is propene. This one is the suffix. When you combine these two, propene, it tells you that the number of carbon atoms is 3, and the family to which it belongs is alkenes. All right, so now, these alkenes, they undergo what we call chemical reactions. That's what you need to know. Chemical properties. I mean, they have chemical properties. So one of the chemical properties of alkenes is combustion. Okay, they undergo combustion reactions where they burn in oxygen to produce carbon dioxide and water. The other one, which is my interest because of the video I'm doing, is addition reaction. Okay, addition reactions. Now, addition reactions, we have the addition of halogens such as chlorine. Okay, so the alkenes undergo addition reaction with halogens. Okay, and the other addition is hydrogen itself. They undergo addition reaction with hydrogen, and this is actually one of the ways through which margarine is made. The temperature there should be around 200 degrees Celsius, and then the catalyst should be nickel. Okay, now my area of interest is addition of water, which is called hydration. Hydration, which is basically the addition of water to an alkene. Okay, so for example, we pick ethene, which is C2H4. We react it with water. Okay, this is going to give us something. Now, hydration of alkenes, basically what it means is that alkenes react with water to give an alcohol. I'll repeat that. Alkenes react with water to give alcohol. Now, this should be, the water we are talking about here is steam. Okay? Why? Because the conditions are that the temperature must be at 300 degrees Celsius, about 300 degrees Celsius, and then the catalyst must be phosphoric acid, and then there should be the pressure of about 65 atmospheres. So the water we are talking about here is steam. Now, what is going to be produced? Well, what we are going to have is the corresponding alcohol. What I mean by corresponding alcohol, this is ethene plus water, which is steam. This should give us ethanol, that is the corresponding alcohol. So ethanol, now how is ethanol written? Of course, we have the general formula for alcohols. The general formula is CnH2n plus 1 OH. This is a functional group which determines the chemical characteristics of alcohols. So when we use this formula, ethanol, remember, F is for 2 carbon atoms, then ano is that it means that it belongs to alcohols. So what it means is that when we put the 2 here, it will be C2, H2N, we put 2 plus 1, then OH, this will give us C2H, 2 times 2, 4 plus 1, 5, OH. This is what we are going to have here, OH. Okay? So, there should be conditions that should be met for this to be achieved, and we are saying that the temperature should be at about 300 degrees Celsius, and then the catalyst, phosphoric acid, and the pressure of 65 atmospheres. So this is the process. Okay, the process is called hydration of ethene or alkene to produce an alcohol. By the way, apart from fermentation, this is the other process by which an alcohol is prepared, particularly ethanol, where the hydration of ethene takes place. Okay, I thought I should mention this. So now, when this happens, you gain what we call an ethanol, or an alcohol called ethanol when you use ethene. Okay, and then now these alcohols also have chemical properties, and alcohols also undergo, like I said, one of the methods by which alcohols are prepared, particularly ethanol, is by hydration of ethene. Okay. Now, the other thing is that what you need to know is that alcohols also undergo combustion. Ethanol burns in oxygen to give carbon dioxide and water. The other thing that happens is oxidation. Okay. Alcohols undergo oxidation. Alcohols undergo oxidation. What do we mean by oxidation? Well, they react with oxygen under certain conditions so that the corresponding acid is produced. For example, when you have ethanol, okay, reacting with oxygen, well, you are going to get a carboxylic acid, which is ethanoic acid. Okay, this one. All right. This is the ethanoic acid that you are getting. Now, the general formula for carboxylic acid is basically CnH2n plus 1 COOH. This is the functional group, the carboxyl group, which basically identifies its chemical formula, chemical characteristics. Now, this one reacts with this. This is also combustion, but because it's producing a corresponding carboxylic acid, it's oxidation. Okay. Now, what you need to understand is that for easier understanding, the N should not start from 1 but from 0. Why? Because this guy already has a carbon. Remember, the nomenclature takes into account the number of carbon atoms in a compound. So because of this let me just zoom in. Because of this COOH, this C is already a carbon. So whatever you put here, if you say 2 for ethanoic acid, then you are going to have 3 carbon atoms. So your N should start from 0 for the first organic acid. So what I mean is that you have C0H20 in brackets plus 1 COOH. You're going to discover that C goes because there is nothing. Then you have 2 times 0, 0 plus 1. So you have HCOOH. And this is called methanoic acid. The second one, which is ethanoic acid, should have 1 here where there is N. So that you have C1H3COO. This is ethanoic acid. Okay? And the process by which ethanoic acid is produced or formed by using ethanol is referred to as oxidation. The process is called oxidation. Okay? That you ought to know. All right. Now, this ethanol can undergo a process called esterification, where an acid reacts with an alcohol in order to produce an ester. Okay? For example, we can say, this is just an example aside from this, we can say methanol plus ethanoic acid. What are we getting? Well, what you need to understand is the fact that there is an order that should be followed when naming alcohols. When naming esters. So the esters are named following this order, that you start with the alcohol. What is the name of the alcohol? Methanol. So you name methanol as methyl. Okay? Methyl. The alcohol is ethanoic acid. This changes to ethanoate. That is the order that you use to name esters. So methanol plus ethanoic acid, the product which is an ester. And let me also make mention that this reaction is also reversible. It is a reversible reaction. So the opposite, and there's also water which is produced in the process. The opposite of this is called hydrolysis. So when you are going this way, this is esterification. Okay? But when you decide to go this way, this is called hydrolysis. Okay? That's what you need to understand on esters and how they are named, basically, even how they are written. So when writing esters, this is methanol. Methanol is HCOOH plus, then you have C2H. Ethanoic acid should be CH3COOH. When you react this, this is gonna give you something like this, HCOO. Then you have no. This is methanol, right? So methanol, this one is an acid. I beg your pardon on this one. This one should be CH 3OH. This is an alcohol. This is an acid. So these two cannot be written like this. I meant this. So what you are going to have here as a product, even this one changes, you're going to have H3COO, then you have your CH3. This one is what we call the carboxylic acid, which is methyl ethanoate. Now, I also want to make you know that when writing, you start with the acid. Then you write it up to here. You leave the H. Why? Because this, not the H, but the OH, this actually forms what we call this OH, this H from the acid and the OH from the alcohol, they combine to form the water, which is also a byproduct. Okay, so when writing, you ensure that you write the part of the acid up to where O ends, then you add the alcohol part without an OH. That is the order that will help you understand this. So let's now go back to the question. What is the question saying? Well, the question is saying the series of processes below show the link to the formation of an ester known as ethyl ethanoate. The question reads to say, from the reaction scheme above, name processes K, L, and M. Well, K, ethene, undergoes a process to form ethane. What process is this? This is hydration. So K is hydration. Then ethanol undergoes a certain process to form P. Now remember that we are going to use that P to undergo a certain process M in order to form ethyl ethanoate. So now ethanol undergoes a certain process to form, because we need this acid. The ethanol is already there, the acid must be there in order to form the acid, the ester. So this alcohol, under the process called oxidation, must form ethanoic acid, which is process L. Process L is it's the process that we are calling oxidation, and then P is ethanoic acid. Process M, this is the process where you react P and ethanol in order to form the ester, and this process is called what? Esterification. Okay, then we move on to question B. Construct the chemical equation describing the process K. Include state symbols. So let me just pause here, because there is some little amount of light which is possibly making it impossible for some people to see. I'll continue this video just a moment.